And I'd also like to do an example where we actually can't use our discriminant to classify our extrema. So for this example, we want to find and classify the critical points for f of xy equal to x squared y to the fourth. And we're going to go ahead and move through this problem as if you didn't know the end story, that this is the example where we can't classify the extrema using the discriminant, because in general, you won't know ahead of time. So somebody just handed me a random critical point problem, and I'm going to plug right into it. I'm going to say, okay, I need to find critical points. That means I need to set the gradient equal to 0. And for me, that gradient is going to be 2x y to the fourth and 4x squared y cubed. And then that gives me two equations. 0 equals 2x y to the fourth and 0 equals 4x squared y cubed. These both look equally bad to me, so I guess I'll start with the top one first. So 0 equals 2x y to the fourth. That tells me either x equals 0 or y equals 0. We'll make this equation equal to 0. And then for my second equation, 0 equals 4x squared y cubed. And let's say I picked x equals 0. Then that gives me 0 equals 4 times 0 squared times y cubed. That's 0. So it doesn't matter what value y I pick. If I take x equals 0, the first equation is 0, and the second equation is 0. So I'm done. Okay, and then there were my two choices, x equals 0 or y equals 0. Let me do some like fancy colors. So my first choice was that x is 0. My second choice is y is 0. Do that right there. So this is going to give me 0 equal to 4 times x squared times 0 cubed. But again, that's going to be 0 as long as y is 0. So then x can be anything. And so when I try to solve these two equations for any critical points that make both equal to 0 at the same time, I'm going to find my possibilities are 0, comma y for any random number y, or x comma 0 for any number x. So just to be clear, this does include 0, 0, either taking x and y 0 here or taking y and x 0 here. But it also includes things like 0, 1, 1/2 0, a million 0, so on and so forth. It's really going to be kind of, here's my x, y, z. My surface is some very steep, bendy thing. I'm actually not going to draw that surface on there because that's just going to confuse you. So all of the x-axis, oops, did it backwards. All of the y-axis comes from setting x equal to 0. And then all of the x-axis comes from setting y equal to 0. And that whole cross of numbers is going to be possible critical points. I'm like, okay, that's a lot. I'm not really sure what I'm going to do here. But the way I've solved it every other time is I've calculated d and then plugged stuff in. So I have something to plug in. Maybe if I compute d, things will work out. Oops. So my grad f was 2xy to the fourth, 4x squared y cubed, 2xy to the fourth, 4xy cubed, x squared. Okay, doesn't make a huge difference, but that's okay. So I know that my f sub xx is 2y to the fourth. My f sub yy is 12x squared y squared. And my f sub xy is 8xy squared. So my d is equal to 2y to the fourth times 12 x squared y squared minus 8xy squared squared. So that's 2y to the fourth, 12x squared y squared minus 8 squared x squared y to the fourth. Oops. So, okay, I'm going to pull out a common x squared y to the fourth. And then inside can go everything else. I don't super care about it. 24y squared minus 8 squared. And then from here, I could kind of stop because all my points are 0, y or x, 0. But no matter what, that term out front is going to be 0. So for all the points I found, if I try to plug them in here, x is 0 or y is 0, doesn't matter what happens in here, I'm going to get 0 out front times a number, still gives me 0. And when d is equal to 0, that's that last case in our list of steps where this test is inconclusive and we actually have to examine f of xy to classify the points that we're thinking about. And that's not super clear. Which is why I wanted to do this example. So now that we've done all this work and found that our test is inconclusive, we have to go back to what f is. So we're given f is equal to x squared y to the fourth. And we know that the critical points we need to classify are 0, y or x, 0 for any values y and x. So when x is 0 or y is 0, f is going to be equal to 0. Either you plug in 0 there or there, but you get f as 0. So for all the critical points, that's true, that f will be equal to 0. When we're not at a critical point, when x isn't 0 and y isn't 0, f is going to be bigger than 0. So you're going to plug in any number here squared is positive. Any number here to the fourth is positive. Product of two positive numbers gives you f greater than 0. So for example, if I plugged in x equals -1, I'll get 1. Y equals 7. Oh, I'm not going to do that. Y equals 1. I'm going to get 1 again. And so f is 1. It's greater than 0. So if at a critical point f is equal to 0, but if at any other point f is bigger than 0, we know that f is smaller when we're at the critical points compared to anywhere else. So that means all of the points are local/relative minima. And again, those points are 0, y or x, 0. And that's the kind of argument you have to make to classify your critical points when the discriminant test fails. So just be ready to make that sort of sort of observation about how your function behaves whenever you stumble into this type of case.